So, let's talk about heavyweight applications for our XTS system. Jan, the XTS applications which I am familiar to, they are mostly about light products, small products at insane speeds. And now we are showing here how we move around some quite heavy stuff. So 15 kilogram dumbbell, quite heavy, already a workout, and this is moving super dynamic on the two-layer XTS system.
Yes.
What can you tell us about this application?
Yes, we want also to show now that the XTS can not only speed and with light products, the XTS can also doing weight. We have here our extended gantry system, which is built from two parallel XTS systems working together. And yes, there are a couple of new things in or features the XTS has, but the most visible directly is of course the weight. And we carry here with two mover near to 16 kilogram in this small footprint, so with a 180-degree curve with a small radius. With other radiuses and bigger mover, we can even go up to 20 kilo per one mover and 40 kilo with two movers. So the XTS is not only light and fast, it's also dynamic and heavy.
Yeah, but still super compact. So it's like 40 centimeters high and only 30 centimeters deep. So, but if we look a little bit closer, if we go a little bit under the hood, what is on the technological side, on the control architecture side behind this demo?
Yes. Also, we play here with one advantage of the XTS, which the XTS had since the beginning.
Okay.
And this is thanks to EtherCAT and industrial PC. An intelligent product transport system, and you know this better than me from XPlanar, Felix, generate a lot of I/O data through the way, and also has a lot of mass to calculate. And now, thanks to EtherCAT, we can all bring this centralized with a small cycle time to the IPC. And as the IPC is so powerful, we can calculate everything there. And so we have everything centralized at one point. And this brings us in the position that we can now switch between technology functions or operation mode in really one cycle. So 250 microseconds, we can change this. And this gives us a great advantage. And one advantage we're really using here, that one mover on one side is in closed loop, position loop, and sharing his force command with his other mover, and they're doing equally and sharing the force completely equal, no tension, mechanical tension between the system, so a perfect use case. And for us it's completely independent if this is on one system or two systems in parallel or somewhere else in the machine.
Could also maybe three systems in parallel. But what is also interesting, I think, is you mentioned that it's a closed loop control, and we are talking in 250 microsecond intervals with the XTS modules from the central PLC, and the PLC typically operates at least the motion part at 1 or 2 millisecond cycle time, and this means we can also react super quick. So if we lose a part of the dumbbell, we would know it right away, right?
And this is not so clear for people coming from other systems, that we have it in the centralized system here. In every millisecond we can react on something what happens in the machine. For example, we have an in-feed where a product is missing, so we can react immediately without dead time, and decentralized system need and have to slow down everything because of this dead time. And just to this feature, we find out in discussion with customer that they can do their machines finally faster.
Yeah, and one thing which I saw in addition has nothing to do with the software in here, and this is about the assembly here, which also makes the customers at least set up the machines a little bit faster, right?
Absolutely. So this is pure mechanic, I would say. We show here first time our new extruded aluminum machine frame to mount the modules on, and this makes the installation of the machine for us and for the customer much easier, much faster, and therefore finally also more cost efficient.
I would like to ask you, Johannes, we introduced the XPlanar 2018 at the SPS exhibition. We introduced it to the market in 2021. So since then, everybody can order it from the catalog. What have we learned since then?
Oh, first of all, we learned that this is a really fascinating technology, which is not only nice to watch, but also fun to think about and to develop and to sell, actually. But we also learned that The XPlanar has many, many different applications. So starting in classical machine building, pharma industry, food industry, also a lot of assembly industry, but also for restaurant applications, for transporting meals to the table, or even art installations. We had all different kind of requests and applications. And while listening to our customers, we learned one thing. When we start thinking about applications, we have to start with the product of the customer.
Yeah. Can you elaborate this a little bit? What does it mean, starting with the product of the customer?
Well, so the XPlanar in first sense is a transport system. So there's a product which has to be transported. This product has a certain size and it also has a weight. So the customer comes, oh, I have this product, weighs 500 grams, and we say, oh, you can transport 500 grams with this small mover, APM 4220. Another customer comes with, oh, my product is 1 kilogram, so this cannot carry 1 kilogram, but this one here can. And then we have the perfect mover for the product, and then we need like the perfect tire, so the perfect motor and engine tire for the mover for space-efficient application.
And let's go to the exhibition wall and have a look at this, because here you can actually see it. This is the existing XPlanar tire, 240 by 240 millimeters, and if we now put the small mover on it, then we can actually see perfect for two-way operation, right?
Exactly, and you always, or in many machines, you need the two-way operation because there's a way forth and there's always a way back, and this has to be as space efficient as possible. So 500 grams with this mover, perfectly possible on the existing tile. 1 kilogram or 2 kilograms with this mover does not fit at all. We need two tiles, so we lose space.
Yeah, so we need a second tile, which means 240 by 240 is then 480, but the movers are only roughly 310 millimeters wide, right?
Exactly, so there we lose 100 millimeters of space. So we developed a new tile which has a different form factor. It's a little bit bigger, the APS 4244, which is 320 times 320 square millimeters. And you see this mover fits perfectly in a two-lane operation on this tile. And we also have another one which is half the size where we can do the one-lane operation. And we have a different form factor, but we did not only make the old tile bigger, we also adapted the technology inside. We learned a lot in the last years, and we get much more precise, we get much more dynamic. So it's also a technology leap for the XPlanar.
Yeah, that's true, but we wanted to keep something, and this was the price per surface area. So if we look at applications with this, then 1 square meter with the new tile is actually just as expensive or inexpensive as with the existing tile. When we look at some applications which we have realized, what can you tell us about the advantages for the customer with this new form factor?
Yeah, for example, we investigated in the application we have in our own production for our I/O terminals, and there we use this mover to transport our I/O terminals. And if we use this tile instead of the old tile, we can save approximately 50% of the space, and that also means 50% of the cost.
Yeah.
So it's not only much more precise and much more dynamic, it's also much more space efficient for many, many applications.
Yeah.
I still remember at the Hanover trade show, we, for the first time, take the buzzword TwinCAT chat. And now I'd like to chat with Yannis. Hello, Yannis.
Hello.
And we need to recall this year's Hanover trade show. For the first time, we had an interface to use ChatGPT into the TwinCAT world, and we call this TwinCAT chat. How was the reaction 6 months ago?
Yeah. The reaction from the visitors on the fair was very, very good and positive. A lot of the engineers, but also the management representatives, see the high potential in this new technology. Some already asked for testing a beta if it becomes available. For our side, it shows the high demand on new solution to support the engineers in their automation workflow.
Now, if we generate interest, which we oftenly have done, people ask us right away, how far are we with the integration? So what is the actual status now?
Yeah, we start in the Hanover Fair with the PLC code generation, optimization, and documentation. Now we add some new features, something like you can predefine your requests you have frequently asked. So it's easier to automate your workflow. On the other end, we also add the knowledge from our automation interface to the models. So we can do something like a natural language, add a terminal via chat to the I/O tree. Another thing is that you also can use TwinCAT chat for creating HMIs. So we have a really cool showcase on this fair. You can also add a picture as a blueprint to the chat, and then ask something like, create me please a HMI out of this picture, and it's worked quite well.
Now, this sounds so simple when you explain this. You just add the HMI possibility, that possibility. So this is just, let's say, good work and then it's done. But what can we expect in the long run? Is there also a bigger scope?
Yes, of course. Now we are started to bring the whole knowledge from our Infosys into the models, so that the customers in the future can just interact with our documentation via chat, can ask the Beckhoff questions and directly get a good answer with the link to our Infosys for more information. And on the other hand, as I also told you, we want to extend the knowledge of the automation interface. So in the future, you can use or modify the whole TwinCAT project via natural language.
Now, for me, that sounds perfect because I'm not a programmer, to be honest. That means me being not a programmer, I just said, hey, TwinCAT chat, I need this function, that function, code is generated, I press the start button of the machine, and that's it? Or do we still need more expertise?
Yeah, of course, it's not quite that simple.
Yeah.
We need the engineers to validate the results and plan the next step in the project. But in these times, with the shortage of skilled workers, we see it's a good answer to solve this problem.
Okay, now we're talking about IPCs, and we go into the C60 family. You may remember, years back we started with the C6015, the ultra-compact, small, compact IPC for new automation tasks. Since then, Anne, we developed a huge range of C60 products, 15, 25, all the way to the 6030. But now we have a brand new highlight on the trade show, the C6043. So Anna, let's do some feature bashing. What is this all about?
Okay, so the 6043 is an extension of the C6040. So also during the development of the C6040, we have ensured that the power supply is big enough that all signals needed in the second layer are available. So on the CPU side, we have the same features like for the C6040. So we have a Core I CPU with the 13th generation, 64 GB RAM available. And in the second layer, so in the right extension, we have an MX-M graphic card with an NVIDIA GPU, concrete with the RTX A500. So this graphic card has about 2,000 CUDA cores, 64 tensor cores, sorry. And also 4 GB graphics RAM.
Wow, so this combines then our PC power together with the graphic card power.
Exactly.
But I mean, I do this now a couple of years in the IPC department. We never used graphic cards for specific reasons. Now the new generation is coming, and boom, we have a graphic card. So why is it now possible to integrate a graphic card also into our IPCs?
So the reason is quite simple. So until now, the applications in industrial environment were sufficient realized with the integrated GPU of the CPU. So the eGPU.
Yeah.
But now the topic artificial intelligence becomes more important, and therefore we need a hardware that is able to process many operations in parallel.
Okay.
So, and therefore a graphic card is well suited. And therefore we have decided to integrate this graphic card inside. And here we have a solution that is long-term available and also suited for industrial.
Okay. But are there more graphic cards to come, or is this the one and only we can offer?
No, so we're starting with this card, so the A500, but we are already evaluating the graphic cards of the next generation, so of the Ada Lovelace generation called, and that will come surely. And this will be also more performant than this one, and so that's very interesting for the high-performance customers.
Okay. I think it's also important to point out now we combine actually an IPC and a graphic IPC.
Yes.
So if we put this together, the customer can still use our typical IPC features for automation.
Yes, of course. So we have a complete IPC on the left side, so Intel Core I CPU, RAM, hybrid architecture in the CPU. So that means we have performance cores and efficiency cores. And we can also use TwinCAT Core Boost. So that's a feature of the CPUs that can be used since the 11th generation. So you can adapt the frequency of the CPU to the application requirements, and so you have the maximum performance. And in addition, you have the graphic cards, for example, for artificial intelligence.
Well, this is perfect. We combine two worlds into just one. Excellent, Anne. Thank you. And now I can invite my dear colleague, Fabio from the TwinCAT team, because, Fabian, now we have IPC power for automation plus graphic power, and you're waiting for this now for a long time. So why?
Well, honestly saying, I'm not waiting for it. Our customers are already waiting for it, because we have many vision customers, and with vision customers also we are faced with different kinds of requirements. One requirement is to run also very large deep learning models, also in very low cycle times.
And what do customers do now with this graphic performance? What is the use case?
Well, use cases are mostly in visual inspection. They want to inspect wood or food, everything that has natural variance. That's where deep learning is very effective compared to conventional vision engineering.
Well, perfect. So we have TwinCAT software available, IBC hardware. That's the perfect match. Thank you.
What kind of terminal do you have in your hand?
It's a GNSS, a Global Navigation Satellite System terminal, so you can connect an antenna and connect to this system and get a synchronization time into your application.
And this seems to be very helpful if I would like to synchronize, for example, many cookie machines all over the world, so I can make sure that the chocolate chip cookies come all out at the same time. But when we talk about synchronization and about accuracy time-wise, we're talking about microseconds. So why would you use this? Why do you want to synchronize everything so accurate?
Applications like radar systems to the sky. When you look to the sky and want to see one star for 24 hours, for example, then the whole Earth is turning, and you have to synchronize all radar systems to see the same spot. And by using this synchronization as precise as 1 microsecond, that's directly connected to the image resolution. So it's really important for our customers to have this really precise time synchronization, for example, in this application.
And you told me another application could be in grid monitoring, that you can find errors in the electricity grid much easier with time synchronized measurement stations throughout the grid, right?
Also correct, yes, because when there is an error in the grid, you want to know where that is. And you measure the grid at certain points and then measure how long it takes that you see the error. And then you can locate the error by having a good time synchronization in your measurement setup. And that is done by this terminal. And just because it is a GPS terminal, it also gets some goodies like the position, the speed, and the direction you're heading to.
Okay, so a wide variety of use cases which I couldn't really imagine. So we can look into the sky and we can find out where the tree has fallen on the power cable. I think that's very useful and very interesting that we also offer something for this. Thank you very much, Fabian, and I would like to continue with some dynamic measurement electronics, because Fabian's terminal needs an antenna. Yeah, and if you are on the shop floor and you want to know about the movements, or if you want to measure movement, then that's not really helpful.
Yeah,
Dirk, what do you have in your hand?
So that's an EtherCAT box.
Yeah?
So we have an EtherCAT connection here. And you're absolutely right. If you are in a hall like we are here on the SPS, there's no direct connection, vision connection to the satellite, so you cannot find any movements.
Yeah.
That's why we integrated a gyroscope for movements, for rotational movements, and a accelerometer, 3-axis both, into this box. That's called an IMU, an inertial measurement unit. So we can measure rotational speed and inclination, angle things.
Okay, very interesting. I think so. This box is more like a sensor, and I can imagine that there are some other vendors for devices like this. What are we doing different, and what is the benefit of integrating it into an EtherCAT box?
Yeah, absolutely. You say that there are sensors like that on the market, not like that, but there are sensors IMUs on the market.
Nothing is like that for sure.
Like that. Absolutely. No, but all these sensors typically use a pre-configured system with a CPU maybe, but they have a very slow communication interface. RS-232 or 422 serial communication, and we use our fast EtherCAT, fast and deterministic, real-time capable, and that's the thing. So when we sample the data, we cannot only transmit pre-filtered data, but we can also transmit the raw data.
Okay.
And on the IPC, then you can really You can do all the calculations on your own. Our customers can do that.
You can calculate them back from the acceleration to the movement and do lots of adventurous things with it.
Yeah, you can do a lot of stuff with that. Yeah, actually.
And what are the use cases which are realized with this? Because this seems to be something where somebody said, man, this would be a nice addition to the Beckhoff portfolio, yeah?
Yep, exactly. First thing, of course, since it speaks EtherCAT, it's perfect. It goes into the system very easy.
Yep.
And applications you ask for that is AGVs.
Yeah, okay.
We talked about that someday earlier already. Our antenna stabilization, what Fabian just
goes hand in hand, perfect.
Goes hand in hand. Or cranes, where you lift goods or loads, heavy loads. And imagine you have like a wind turbine and the blade is swinging and you want to stabilize that thing. Okay. So that is a good application.
My dear colleague Christian has news for us in the motion department because they also do something simple. You take a stepper motor, we know steppers, but you also take the amplifier, we know amplifiers, and now you combine this. So why the hell do you combine amplifier and stepper?
We did that with a servo motor and a servo amplifier 2 years ago, the AMI 8100, and that was so successful that we introduced last year the next bigger one.
Yeah.
And now we go one step down and introduce the stepper motor. That is a so-called cheaper motor, but the good thing is that it's an integrated drive on this stepper motor and integrated encoder. So we have closed loop control of the stepper and it behaves like a servo motor.
That means in this very small footprint, you have both units combined, the motor and the amplifier.
It's a bit easier because the servo motor has 3 phases, the stepper motor has only 2 phases, but in general it's the same thing. Yeah.
And now, are we only going to use this in this very small footprint, or will this be also a scale of products?
Yeah, this is what we introduce now, and we want to extend these stepper motors and the range of these. So this is so-called NEMA 17, and we extend that to NEMA 23. That is a 56 millimeter range, and then later on to NEMA 34, which is 86 millimeter of frame size. So a very big stepper motor with an integrated amplifier.
Now I noticed you can't make it smaller because you have limitations with cables. So what cables and connectors do I need actually to power it up now?
Yeah, it's different to our one cable technology.
Yeah.
We have a lot of connections here, but we need power for the motor, so 24 or 48 volt of power that it turns.
This is
but
the
we need
one
also
at the top,
control
right?
voltage, so 24 volt control voltage, which is both integrated in this connector. Then we have some IOs. So some of our customers want to do homing, a homing procedure, for example, or start whatever process over the network, and can do that with these IOs here. And then we need, for sure, EtherCAT to get the connection to the IPC.
Yeah.
And these are these 2 connectors, EtherCAT in and EtherCAT out.
Yeah, and I was told that we need EtherCAT in and out because these are normally running also side by side. So in the real application, people have more than just one. So what is then an application case?
A typical application would be woodworking.
Yeah.
So if your wife wants to get a new kitchen, it should be
we have already a new one. This is done.
It is definitely different to that what your neighbor has.
Yes, that's
so a kitchen is an individual project. So the company who does this kitchen and manufactures the kitchen does everything individual. So the color change for each kitchen. And therefore we need these edge bending, for example. So different colors of edge bendings. And with this small motor we can then change the edge bendings, which color should be the next for the next board. And in a typical machine are minimum 30 to 50 to up to 100 of these edge bending materials, and has to be handled. And we need 100 motors then to do that, to switch between the different edge bendings.
And it's a pleasure for me now at this trade show to invite Christian from our Vision team. Good morning, Christian.
Good morning.
And we would like to talk about the feedback from our customers when it comes to our Vision products of optics, cameras, illumination and units. So what are first responses?
The first response is that the customers really realize that we have a nearly complete portfolio. So we have cameras, we have illuminations, we have lenses nicely suited for our cameras. So they realize that they can set up a whole vision application using our own components. Together, of course, with TwinCAT Vision, so our image processing solution in real time.
Okay, now this is, from my point of view, a bit theory. Now we have to touch base in the practice. And I know that you visited already a customer for a use case. So what is this all about?
Yeah, that's true. We have a very good customer. The customer is called Syntegon, and he has set up a technology demonstrator, and there are some vision components from us integrated. There are 2 ring-shaped illuminations. There are 2 cameras integrated, and what you can see is that the illumination is operated in this flashed operating mode, and that means we can freeze the motion of the products moving below the camera.
Now, this sounds interesting, but we still need to find the benefit of this system versus other systems. So what is the real benefit for the customer?
Yeah, that's true. The thing is, the customer is already using a Beckhoff control. So we just have to buy our vision components. So there is no need of a special vision, dedicated vision solution. So we can use our controls to set up this solution. And the thing is, if you may have noticed that the product is moving and the image is taken whilst the product is moving, and that's really nice. So it's not like this that the machine has to wait for the image to be taken. It's all done in a continuous flow, and this improves of course productivity.
Well, we started Tuesday with a statement to Hans Beckhoff, speed matters. I think this is another example. Speed matters, so we can simply produce or control parts faster. Excellent. Now, no trade show without a news. I think the hardware is more or less ready. Are there news in the TwinCAT software vision?
Yeah, there's always things to do in the software and always things to improve. So at the end of this year, we release a function for TwinCAT Vision for machine learning. This is classical machine learning. When I say classical machine learning, I mean support vector machines or random forest, for example. Additionally, we are going to introduce OCR, so optical character recognition, so customers can now read text. Next year, we are going to enhance the machine learning part in that way that you have the possibility to load neural networks, train neural networks into TwinCAT Vision and do the inference in real time. Additionally, there will be another thing where there will be the code grading component, and this means customer can now grade their codes, for example.
The CX7000 is what we call a small controller, but it still has a 480 megahertz CPU, and it comes at a fairly low price. Ralf, what is exactly a small controller?
Yeah, a small controller, like the name say, it's a small controller in a small housing.
It's like a bus coupler, right?
Yeah, it looks like a little bit like a bus coupler but with more IOs on board, because a small controller has also onboard IOs.
Okay.
Yes, which you can use for different applications. We have 8 digital inputs and 2 and 4 digital outputs, and you can configure this. We say this is multi-configuration IOs. You can use it as fast counter, incremental encoder. We have 2 analog inputs on this multifunctions IOs and PWM signals.
So all of these IOs, which you have here as a multi-IO, they are usually separate terminals, as I know. And if you would buy all of these functions, I think you would almost have the price of the CX7000, and there you get the SPS or the PLC basically for free, right?
Yeah, that's right.
Yeah. Very nice. What's so special about our small controller? There are some in the market, right?
Yes, this is the market. The special is at first the programming tool. The programming tool is TwinCAT 3.
Okay.
Which you can use for the small controller up to a many-core PC. So you can use the same libraries, the same software, also for the small controller.
Again, scalability. It's always the same interface for the customer.
But important is also that we use here EtherCAT as master. That allowed the customer to use 1,200 different slaves, what we have in the moment, to connect it to this device.
Yeah. So the openness of the EtherCAT technology gives you many possibilities, just like with any other controller. So it's really a full Beckhoff controller in every sense, yeah?
But you can use also third-party devices from our members, from the ETG.
Yeah. So that's very nice. I can imagine that such a small device, I also see different electromechanical interfaces here, that they basically call for edge computing or to be used as interface devices. What can you tell us about this?
We have new now different field bus systems. New is that we have an interface for CAN as a CAN open master and a CAN open slave, and we have also a new interface for Profibus.
Yeah, that's very good, and I think the openness of this technology is a good call to action for all of our customers, because this really is a proper controller which can be combined with all EtherCAT devices, with all Beckhoff IOs, yellow, blue, doesn't matter. And it comes at such a low price point that the PLC is basically for free, right?
That's right. And what we have also new is that we have also new function inside, yes? Yeah. With a new image, this is allowed you also to communicate in the cloud.
Yeah, okay.
But before we talk about Motion Control 3, I think it's important to highlight that with the NC2, we have 25 years of motion experience. So what is this all about?
Definitely. So we are doing TwinCAT motion controls and more than 25 years meanwhile. And we have a lot of PTP applications running with simple applications, but also complex applications with camming and flying saw. We have interpolated movements with complex milling machine, tooling machines. TwinCAT motion control is used for XTS and also in the show business.
Yeah. Interesting is that Hans said with MC3 we will break a limit of 255 axes to more axes. But I remember that we have already today applications with more than 255 axes. So how does this work together?
That's totally correct. So in past we also did applications with 1000 axes. That was a good time for you because you could were able to sell PCs.
Yes, right.
So in this case we have had different CPUs and we have to synchronize them together. What is a little bit more complex. And now with TwinCAT MC3 we are able to run more than 255 axes on one system, on one CPU. And so we don't have this fixed limitation anymore, it's gone. And we also have this multi-core support. That means you can, if you have 8 cores, you can, for instance, running 4 cores with TwinCAT motion control.
But that means by open up the limits or breaking the limits, we can increase performance or we simply save money because of less hardware costs.
Yeah, definitely. There's also a lot of applications in the field where you don't have this 100 axes. So maybe an application with 10 axes. And also these applications have a big advantage of MC3 because there it's also possible to run, let's say, 2 axes with 1 millisecond cycle time and 8 with, for instance, 4 milliseconds.
Yeah. So I think a lot of customers are really waiting for MC3 because with all this new flexibility, higher performance. But what do they do if they still want to maintain some of the existing NC2 application and would benefit from MC3?
So in general, the kind of programming inside the PLC is PLC open-based motion control, what we are doing for the NC2 and also for the MC3. And also one big advantage is that you can combine NC2 and MC3 on one solution. That means you can run new parts of the machine with MC3 and the old parts on the same CPU in the same TwinCAT solution, still with NC2 going on.
Oh, Klaus, this is perfect. I love these simple messages.
We tried to reinvent control cabinets and we wanted to make the machine control cabinet free with the MX system, but we are standing in front of a big control cabinet. Marvin, why is this the case?
Yeah, so a control cabinet is that what the people are familiar with. This is not the first cabinet that we brought to a trade show, but this is definitely the biggest one. So we just want to present that the MX system is also capable of bigger infeeds, bigger machines.
Okay, so this looks quite spectacular. I see a lot of color, and I assume this has a reason. Can you explain me what's behind the color and how we can translate it maybe into the MX?
Yeah, so it's not only the biggest cabinet, but it's also the most colorful.
It looks very nice.
Thank you. So we try to distribute it into different functional bundles so that a machine has different process stations. So these all correspond to a specific station in a machine. And maybe we can go over here because this is the conventional stuff.
So this is the translation to MX, which we also like to support for our customers always, right?
That's right.
Yeah.
And here you could find the equivalent of that cabinet, but now in a modular design. So we find MX system for each and every station, so we just mount them exactly where they need it.
So this is like a translation wall for classic control cabinet to MX, also with colors. Right. And I can see that we have some new modules. I see these big modules and I see these ones which look a little bit unfamiliar to me. What can you tell me about these 2 modules?
Yeah, so bigger cabinet means also bigger energy consumption of the overall cabinet. So we also need bigger infeed on the MX system. So we introduce our size 3, which means we have bigger base plates, which allows us to not only mount more modules on there, but also to mount bigger modules on there.
Okay.
So this is an infeed module capable of 63 amps.
Wow.
We go up to 125 in total, and we also have bigger DC links, bigger drives, and so on. And the other thing you mentioned down here is our pneumatic integration. So we now also bring the pneumatics onto the MX system.
Yeah. And so this is really interesting because we enable many more use cases, we enable more powerful drives, we integrate the pneumatic part of the machine. And then you have especially asked me to talk about one more thing, which is about power supply, because many people need pneumatics, for example, but everybody needs 48 volts, right? And we have something quite special, which is not so uncommon, right?
So here you can see a regular 48 volt power supply.
Yeah.
It is capable of 40 amps.
Yeah.
So we can use it for our compact motion.
Yeah.
But
you can also use it for other products, right?
Right. We have also other Beckhoff products that need 48 volts and also a lot of power. So we can also use these with different interfaces on the front so that we can connect, for example, our Atro, we can connect our XTS, and for example our AMI motors.
So the MX system is really the starting point for the entire automation of the machine and integrates nicely and seamlessly with all other Beckhoff technologies.
That's
right?
a nice conclusion.